identity proofs. That's going to be another part of what we want to make sure we know how to apply. It's not so much proving identities, but knowing our identities and be able to manipulate them algebraically. So here we have an identity proof. One thing we could think of doing is cross multiplying, but technically we shouldn't really be doing that. So we're going to just avoid that and do it like this. I'm going to find a common denominator for both sides. So I'm going to multiply 1 plus cosine x on this side, and I'm going to apply it to the denominator and the numerator to keep it all the same. And on this side, I want to have that same denominator. So I make the denominators match. Usually the numerators will match. So sine x times that. So I'm missing a sine x factor here. So I'm going to multiply the bottom by sine x. And I'm going to multiply the top by sine x. Okay, and there I've kept this left side the same. I've kept the right side the same. I now have a common denominator. So I end up with this expression that looks like this. So sine squared x over sine x, 1 plus cos x, and this side's going to be 1 minus cos squared over sine x, 1 plus cos x. So I've made the denominators match. I don't need to touch those anymore, and I can see the numerators. I can either convert the sine squared into 1 minus cos squared or the 1 minus cos squared into sine squared. I'm going to do this. I could have done some simplification as well. There's a lot of things I could do, but really I'm just trying to make the left side and right side match. Okay, so there's, at this point, my left side and right side match. Although I certainly could simplify this, I'm not going to bother because as long as they match, I've proved the identity. So this one here, we should really look at, the first thing that should really stand out is there is a Pythagorean identity there. We should really apply that. So I end up with sine x. Well, the other thing I'm looking at here is this is one term here, and these are two terms here, and this is going to be a third term. I can really kind of break this down into, this is just going to be sine x over cos x, and I see that I have a minus 1 here. I see I have a plus 1 here. Those are just going to cancel out. So I'm going to do that. So I'm going to go minus 1 plus 1 equals the right hand side. And once I've done that, I've essentially solved this identity. Okay, so these are going to be 0 pairs, so they cancel out. We end up with tan x on the left side. The right side is also tan x.